So first of all, you have to find the force and determine the x, y, z coordination of point A, but you got the force here, so you have to know the magnitude of the force. So it could be like it could be, and you know the angle of the force, so you can know. And you got this angle, so you can figure out the magnitude of the A, and AX it would be like, and you know the cable AB is 9 meters long, so it would be 9 times cosine that angle you find it is alpha, so it's cosine alpha, and it will be minus 5.606, and AY will be 9 cosine beta, will be 66.32 and then 3.61, and the AZ is 9 times cosine gamma, and it will be 6.550, and the answer is And then these questions, we got the 6 equal 4 and meter and y equal 2 meter. So the A point, we can know A point is like 4.2.0, but we don't know the B because we don't know the Z. So we write down here, it's kind of 0, 0, Z. But we know the BA of the magnitude of the BA, so we write down like 4 minus 0 is 4, and 2 minus 0 is 2, and the 0 minus Z is minus Z, and the magnitude BA is like 4, 2 plus 2, and the question tells us is the total long is 8 meter long cable, so we know here is 8. So now we can calculate the Z, and the Z would be like this, and it also equal 6.63 meter. And now these questions tell us the x equal y and its total length is a meter long cable. So we can know the point A here, and we know the x equals 0, so we kind of like just write down x, y, and 0, and the point B here is 0, 0, z. Oh, and the z tells us equal 5, so here is 5. And now we know the BA is minus x minus, the minus y equal x, so we can just write down x and minus 5 here. And we know the magnitude of the BA is like function is like this, and so we all know it's equal A, and here we can calculate like this, 2 plus 25, and we know this is like 19.5, and we know the x is equal 4.42 meter. Now the question asks us to determine the member of each force about the bolt located at A. So point A is here, so we have to calculate each member at the point B and the point C. So first of all, we calculate first at the point B. So summation MB. It's like and if we have to calculate the moment, we have to use this function, but the force is not like this, so it has the angle, so we have to calculate like 200, FB is 200 times cosine 25, and the distance is 0.75 m. So we know the answer is 136 in m. And the summation MC, see here, is like the 250 times cosine 30. And the distance is 2 plus, so it could be like 0.975. So we know the answer is 211. And the next one, we have to calculate it tells us we determine the result moment about the bolt located at A. So the whole thing is equilibrium. So we have to find out the summation. If the summation MA is equal to 0, and there's two forces, like force B and force C. So we start at force B, and also times cosine 25, and the distance is 0.75. And then and the cosine FC here, the force FC cosine 30, and times the distance is 975. So we got the answer is 292. And the next question is to determine the moment product by the force C about the point 0. and it have to express the result as a Cartesian vector. So first of all, we have to find out where is RAC. So RAC, it means like a C minus, the point C minus point A. So it would be like 2I minus 3J and minus 6K. And we have to know the magnitude of the RAC. So it could be like 2 squared and it's also squared and root then, so it will be 7. So now we know the force here, force A is 420, and we have to know the Cartesian vector at the FA. So the function is like the F times like the R. So it could be like 200 times. At the 7, at the x-axis is 2. And the y-axis is 3. And the z-axis is 6. So it'd be like I, J, and K. So now we know the force FA, and we have to calculate like the R, the point O to the point 8. So we can calculate the moment C. So the ROA is like 0, 0, 6, because it's here, really 6. And we know the moment, the function is like ROA cross F. So it would be like this, 0, 0, 6, and the force here and the answer is like that. And now the next question, we have to determine the member product by force FB and FC at the point O. So we can write down RAB, and it means the distance of A and B. So it could be B minus A. So we know it's 6K. And we know the magnitude AB is 25. And root then 65. And we have to figure out the FB and the result as a Cartesian vector. So FB, F, and we have to times G. Okay. And we know the answer is 300J and minus K. And we have to figure out the moment at the about the point 0. So the R 0 B is 0, 0, and 6. Okay. And we have to know the moment. The moment function is like this. It's ROB cross F. be like I, J, K, 0, 0, 6, and 300, and minus 720. And we know the answer is minus 720 I and plus 720 J is the answer. And now we have to calculate determine the member of these force about 0.8. So first of all, if we have to figure out the moment A, we have to find out the force here. So the force here is like F equal 80 cosine 30 and sine 40, and also plus 80 cosine 30 cosine 40 and minus 80 I, J, sine 30 K, and it will be like 44.5 I plus 50.07 J and minus 40 K. Here is the force that we want, but now we have to figure out the moment A. So we also use the function here, the M FA, the summation MA, and the I, J, K here, and the distance from point F to the A is like 0.55 and 0.3 and minus 2, and this into here minus 40, and it will be like minus 5.39 I and plus 13 point J and 11.4 K is our answer. Here is our answer. And now we have to figure out the moment at the point B. And the point B is here, so its distance have to be FB. So summation MB. And the distance we have to change from the F to B. So it's 0.55, 0. So the answer would be 10.61 I plus 13.1 J plus 29.2 K, and is the answer for the 35. And now these questions we know is equilibrium. So the summation f x equals 0, and all the force on the fx is this and this. So we have to calculate in the x-axis sine 30 and minus 700 and sine 7. It would be like minus 125. And the summation fy equals 0. So we know the force in the y-axis is like 100 minus cosine 30 and plus this, and also plus 700 and cosine 30, and it will be like this. So we know the force here, and now we have to calculate the theta angle. So we know the function is like that, Fy and Fx, and F here and Fy here, so it will be like and it's 84.5 degree. And we have to know the moment at the point 8. So this is what we have to calculate. Summation MA is like, if we have to decide if that is a minus or plus. So here is minus, so 30, and times the distance 2, and minus 30.6 distance, and also minus 700 cosine 30, and the distance is 9. But here also has the moment, so it's minus 1050, and the answer is minus 3535.338, and that's our moment A. And our moment A here. And now we have to calculate like where the force at. So we have to find out the moment and the distance. So if our force is like this, and the function is m equal f times d, and we know the m is minus 9,535.38, and equal, we don't know the d, so it's what we need, and the force is 1,295.93. So the d is equal 7.36 meter. And the next, it says replace the loading by the single result force, specify where the force acts measures from the NB. So now it's here. So everything is moved from A to B, but the force is the same because it's also equilibrium state, and the angle is also the same. But now we have to calculate the moment at B. The moment B here, and B here is times cosine 30 times the distance 4, and minus 700 and cosine 30 and times 3, and minus the here, and it will be minus 1759.81. So we have to know the M equal FD, so we can find the D. So it's like the moment for minus 1759.81 equal the force here times Z. So we can find the D equal 1.63 meter. And this question, it says replace the power load force system acting on the plane by the result force and specify its location on the XZ plane. And now we know the FR X force is 0 and the FR Y force is this plus this and plus this, so it's 10 kN. And the FRZ is also 0 because we don't know any force on the Z plane, and we also don't know any force on the X plane. And now we have to figure out the moment at the X axis. It's axis is here 3, and the distance is times 0.5, and also here 5, and the distance is 1 plus 0.5, so it could be like 1.5. And it's also this force 2, and times 2.5, and get the answer minus 14. And there's also don't know any moment at y-axis is equal to 0 because there's no force on the y-axis, but also have the moment at z-axis. It's also 3, and it's our distance here, so it's like times 1.5 minus 5 times 5. The distance to 5 and the 0 axis is 0.5, and the distance to the 2K to the Z axis is 1.5. So we know the answer is minus 10. And at the x-axis, and we know the moment is equal F times D, and know the moment here is minus 14, and we don't know the distance, so the force is here 10 and the D, and we know the distance Z is 1.4 n, and in the same Z axis is minus 10 and equal minus 10G. So we know the distance x is 1 meter. And the next question we know is the distributed load. And so we had to figure out the F. Where is the F? And for this question, I kind of like to divide the force to this triangle and this triangle. So it could be like here and here. So F is 3 times this triangle here is 3 times the 3, and it is triangle, so it could be had a half, and plus this triangle 3 times the distance, and it is triangle, so it have to be the half. So the force is 6.75 kN. And the moment here, and so this force, this triangle's force, bigger times force, and times the distance. And we know the triangle, the central is on the 1/2, 1 and the central is kind of like 1 and 2, 1 and 2. It's in the one-third. The central is 1/3. So if here is 3, so we have to times 1/3. Here is 1, so it's 1 and 2. And so now the force and the distance is 2, and the plus 3 times 1.5 and half, and the distance here is also the 1/3 here, so it's 1 and 0.5, so it's 3 plus 0.5 is 3.5 here, and the moment is 16 and 875 kN. And we know the function moment here is F times D. So we have to calculate the D. And we know the moment is this, and the force is this. So we know the D is equal to 2.5 N. And now the last question, and is also the distributed loading, with the equivalent resource force and specific dislocation on the beam, and measure from the pin at A. So pin A here. And I kind of like divide this figure as the triangle and the rectangle. So the force on the centroid on this triangle is also here, and the centroid of the rectangle is on the middle. So is the force what we need. So the force here 2, and the distance is 3 and 3, and 3 plus 3 is 6, and plus here the triangle is 4 and 2, so here is 2, and the distance is 3. It's 2 times 3, and it's the triangle, so you have to be half. So it's 50 kN. At the moment here is 2 times the rectangle. The centroid is on the middle, so it's 3. And the triangle here, and the centroid is on the 1/3. So it could be like here, and we can divide it into 2 and 1. So it's 2 plus 3, and it's 5. And the answer is 51 kN. And now the function moment is force times D, and we know that moment is 51 and the force is 50, and the D we can calculate is 3.4 M. is the answer.